Hello, my name is Walter Unglaub, and this is the effect of height on density in physics. Okay, so if we consider the surface of the Earth, we see that we can go up in height, which means we're receding away from the surface into space, and we want to consider the effect that this height might have on the density of some object that is leaving the surface of the Earth and going higher and higher. So we have to understand the definition of density. Density is equal to the mass of the object in 3 dimensions divided by the volume that that mass inhabits. So we see that the mass of an object, if we're considering an inertial frame, it will have just a rest mass, meaning it's not accelerating. And this mass does not depend on height. This is how we write such a statement. It is not equal to a function of mass that is dependent on the height. So we see that the mass remains the same regardless of the height or regardless of where that object is in the universe. Likewise, if we're just considering an inertial frame, that means that length is not being contracted if there's no acceleration going on. So this volume will also not depend on height. Therefore, because the only 2 variables that the density depends on do not depend on height, then the density itself can be said to not depend on height. So the answer then is that the height has absolutely no bearing on the density, provided that structurally the mass remains the same. And of course, situations can be more complicated, but generally, from definition, the density is independent of the height from the surface of the planet. My name is Walter Unglaub, and this is the effect of height on density in physics.